Hello guys, welcome back to another qualification video. Today we have yet another question here. This is from the COMC 2017 contest, and as always, let's first start out by reading the question. So, let XYZ be an acute angled triangle, and let's let S be the side length of the square, which has two adjacent vertices on side YZ. Now, one vertex on side XY and one vertex on side XZ. So, let's let H be the distance from X to side YZ, and let B be the distance from Y to Z. So if the area of the square is 2017, determine the minimum area of the triangle XYZ. So first, before we start anything, let's label these 2 points as P and Q. So let's label this point here as P, and this point here as Q. Now that we have this, we know that the height of the triangle is going to be represented by H, and that the base of the triangle is going to be represented by B, and that the side length of the square is going to be represented by S. So here, let's look at triangle XPQ. XPQ, we have this side length here. We have XP, XQ, and PQ, which is going to be equal to S. And then we look at the bigger triangle, X, Y, and Z, we have B on the bottom with a height of H. And we can see here that for the height of XPQ, the height of XPQ is going to be the total height of XYZ or H minus this side length, which is also S, of XPQ's height, so H minus S. This means that we can see that the similarity between XPQ and XYZ. Why is this? Well, because we know that this square right here is a square, and that means that the bottom side and top side have to be parallel to each other. And since we know that the bottom side is on the same line as YZ, we know that YZ and PQ have to be parallel to each other, and so this means that these angles here, so XPQ and angle XQP, have to be the same angles as XYZ and XZY, and obviously both these triangles share the same angle X on top. So from here we can see that for XPQ we have S, and this is going to be divided by B, or the base, and this is going to be equal to H minus S divided by H. So in other words, we have the base for the big triangle and the base for the smaller triangle, along with the height, as I said before, H minus S, because we need to minus this part, divided by the height of the bigger triangle. So from here, let's isolate B and move all of the other terms to the other side. So as you can see here, how we do this is that you would cross multiply. So B times H minus S, right? This is going to be equal to SH. And after that, we divide H minus S on both sides to receive B is going to be equal to SH divided by H minus S. So I'll be getting back into this later, and we'll be using this later. So let's look at XYZ, for example. We need to find the minimum area of the triangle XYZ. So let's see what XYZ's area is. We can see here that, alright, A, XYZ, so we know that that's the area of XYZ. We can see here that this is going to be equal to base times height, or BH, divided by 2. But we just solved for what B is in terms of S and H. So let's plug this into here. Then we will receive H squared times S divided by 2 times H minus S. Okay? So this is also the area of XYZ. From here, we can see that we need this to be as small as possible. And for H squared times S divided by 2 times H minus S in brackets, for this to be as small as possible, it's reciprocal. So it's reciprocal already here. 2 times, that's 6 on H. I'll erase that. I'm going to write H minus S divided by H squared times S. This is the reciprocal of this equation, right? This has to be the max. So in other words, we want this to be as small as possible. We want this to be the minimum. So in order for this to be the minimum, its reciprocal has to be the maximum. So we'll be using this now. So let's look at this. Equation here. 2 times H minus S divided by H squared times S. You see, this can also be written into -2. So using if you expand it, we can then receive this. That's an S, by the way, I wrote it wrong. Yeah. So we have this. So we have negative 2 times 1 over h squared plus 2 over s times 1 over h. As you can see here, this is actually just a quadratic equation. So let's say 1 over h is going to be equal to x. Okay, let's just say that for now. So plugging this into here, we'll see that this turns into negative 2x squared plus 2 over sx, right? So this is obviously a quadratic equation, and we can solve for this to see that x here is going to be equal to, so actually I don't know why I wrote an equal sign here. X here is going to be equal to 1 over 2 times 1 over s. And since x is also equal to 1 over h, as I said before, this is going to be equal to 1 over h. So essentially, this is a quadratic formula. If we just let 1 over h be equal to x, and after that we can turn x back into 1 over h, we can see that 1 over h has to be equal to 1 over 2 times 1 over 3. Now this quadratic equation here obviously has two solutions. We have this solution here, and if x is equal to 0, but obviously we can't use x is equal to 0 because 1 over h cannot be equal to 0 because, well, the numerator is 1, and unless this h is equal to infinity, which it definitely isn't, this can't be 0. So this means that h here is going to have to be equal to 2s. And this means here that we can then go on to solve for b. So going back into here, we can see that this is now that we have 2s here, on top we have 2s squared, on the bottom we have s, and so b is also going to be equal to 2s. So now we know that h is equal to 2s, and b is also equal to 2x. So this means that going back to the area of bh times bh divided by 2, this means that the area of xyz, or base times height divided by 2, is just going to be equal to 2s times 2s divided by 2, or 2s squared. And this is going to be equal to 4,334. So this means that the minimum area of xyz is going to be equal to 4,034. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments. And thank you guys for listening. Bye.